friends, I am Sunny. Today I am going to make video in regard to introduce different types of tooling required in manufacturing industries. If you see the tool nomenclature, it's really impossible to live without tool nowadays. So from home to driving to industry to a shop, everywhere we need a tool to move. Okay, so if you see an example at home, like I brought some tools from my kitchen. So if this is the tool, okay, like if this tool is used in our home for day-to-day applications where you have to pick up a hot pot or something from the gas stove. So if you pick it up directly, you would not be able, your hands will burn. So this is the good tool, like where you hold, like this is a scissor mechanism with the help of which we pick it up. Now like another tool is like the same, like if you want to pick some delicate object or some kind of finger chips or something, or some kind of roti, so you can pick it up with the help of this. Like this has got a long span and this is a springing effect, so that when you release it comes back to its original shape. Okay, and also it has got a gripper to grip it. Then we have different type of kitchen tools, like a very highly used a fork to pick up some object which can be pierced in this, and then you can pick it up. You kind of like another different types of like when you have to pick up, like pour some liquid from the jar to some place. These are the different tools. Or when you want to like secret something. So these are different tools from kitchen. Then I have like you have some tools from your office stationery or school life. Like with the help of this, everybody knows this, everybody would have used this in his school, that you can draw a line, you can measure, you can draw different types of shape, different types of curve, oval, then you can measure angle. So in one thing there are a lot of tools. Okay, then you have this a very highly used pens. This is one type of tool, like where you can hold, there's an ink in between, and then ink comes in and you can write it. Okay, so there are a lot of tools in our day-to-day life. So if I go ahead and see in our office, like this is the press tool, where when you press it, you get a piece which is bended. Everybody knows this, and this you cannot hide. It's like hardly impossible to run an office without this. So this is where it gets pressed and shaped in this way, and this is the pressure which presses the pin. So when you press it, it comes. Okay, so when you press it, you get it. So whatever is in this between, it enters into that and then curves around. So we get a locking effect of pages. Now like a screwdriver, like there are a lot of home tools which is impossible to run your life without it. Okay, so now if I go ahead with the definition of tool. Okay, what is tool? Okay, like in order to meet huge demands of quality goods, production of products has to fast, and that too meeting quality standards. As a result, there is huge growing demands of tool techniques recently. Now, if we enter a workshop, any manufacturing workshop, you will find lathe machine, milling machine, drilling machine, hacksaw machine, bandsaw machine, then you will get grinding machines, press shop, like press machine, so injection mold, and some other type of pen. But these are the basic machines. So now if we go like and see these are the conventional, then we go that is non-conventional, that is CNC. So there are a lot of things, like if these machines, like if you see example of lathe machine, there would be a spindle and then you hold the job here. Okay, so now holding the job, you need a fixture. Okay, and then the job, when the job is holded with the help of chuck or something, so everything require a tool. Okay, so now for that purpose, if you have a complicated job, you need some kind of fixtures to hold that job, properly, to get the center of that job. So these are the things which are really required. If there is no tool, you cannot make complicated things. You need a tool to hold a complicated job. So when the complexity increases, you have to get a tool. When you need accuracy, you need tool. And third, reproducibility. So now if I hold the job and just turn it, and then I get some dimension, like say I've got a job of 12 mm and then I am turning it to 10 mm. So okay, fine. Now I'm taking second job and again turning from 12 mm to 10 mm. So some job will be 10.2, some job will be 10.5, some job will be 10.8. So you don't know, because you don't have a fixture which holds it, grabs it and locates it. So in this way you need different type of tools. So now I will start with some basic types of tools where you will be able to. Now I will start with different type of tools. First, if you see this is like various types of tool. That is sheet metal. Okay, in sheet metal, if you see, there are different types of tools. That is press tool. So now we will start with press tools. Okay, so that is sheet metal. So now if you go to sheet metal, there are different types of sheet metal like press tool, in which punching operation and all kind of basic operation, that is blanking, piercing will come. So now if I give an example of punch and blank and pierce. So now you know, everybody know this. This is a washer used in like almost every industry, every assembly part, wherever like you need a nut and bolt assembly. So now if you see, there is one hole in like in the inner diameter, and then outer diameter is being cut. So now this will go in like punching and like piercing and blank tool. Okay, so pierce and blank tool, like there will be one sheet going on like this, and then you will be cutting. With the help of press machine, you will be able to cut OD and ID at a one time. Okay, now next we go for shearing tools. Now if you see, we have always a limitation of, from market you get full sheet. The sheet size, standard sheet size approximately is 1250 by 2500. If you see in feet, 8 feet by 4 feet. So then from that you have to shear the pieces according to your size. So now if I have a sheet of 1250 by 2500, and then if I need to cut a washer from that, so what I will do is take this washer and then I will cut this part of sheet. So now if I have now you will be cutting these strips from a single sheet, and then that will be loaded to the press machine, where there will be a blank and pierce tool on the press machine. So now this will be cut with the help of shearing. So you load the sheet and shear it. You load the sheet, shear it. So this is called as shearing operation. Okay. Now third one is bending tools. Now any bending tool you see, Here cutting, in the bending tools there are like no cutting operation is there. The part is bended according to the profile, and then if you see this, and you will find lot of these type of products in your day-to-day operations. Then this is like used on bullock carts or the below the chassis, truck chassis, where the chassis is being mounted in between this, and then the trailer is being inserted into this, and then you just lock the bolts. So this is also bended. This is called a C bending, where you bend this according to the C, and then spring back will be there. Okay, this spring back term I will be considering, I will be taking in detail in my video called bending press tools. Okay, so then drawing tools. Okay, like whenever you see some kind of tumbler or something in your home, you see a draw. Like if you see the water tank or petrol tank of your car, all they are drawn, or the hood of your car, the front bonnet of your car, these are all drawn because the sheet is straight, and then you draw it in different shape. So now if I have one, you would be having one tumbler to store milk or something in your home. So how do you, so these, so this is being drawn. So this big sheet is there. If you see the top view, this will be around where you are converting this to a big shop. So this is done in stages, like 10 stage process, 11 stage process. So this has been done with the help of draw tools. Now I will head to plastic tooling. Everybody know that it has been impossible to live without plastics. A plastic can decrease the cost. So if you see, many parts of your car has been converted to plastic. So plastic is very easy to make, very cheap, and like, but there are like environmental problems which are being going on. A lot of people are replacing that. But I will just go like a big application of plastic. So now this, if you see the plastic, first is injection mold. Okay, if you see this is injection molded part. Okay, even this part is injection molded, and even this part is injection molded. And if you see this cap, injection molded. Now if I go ahead, and if I show this is the injection. Okay, so what is injection molding? Okay, so now if I draw a top cavity, 1, 2, 3, 4, and okay, this is bottom half. So same will be the top half. So now if I see the top view of this, so there will be one, and this will be the bottom half, top half. So now half of the cavity will be here, half of the cavity will be here, and then there will be one piercing hole. So now if this liquid, the raw material is melted and then converted into a liquid form, and then this liquid form is pressurized and then this liquid form is pressurized and filled into these cavities. So now when this cavity is filled, and then when you fill this cavity and let them allow to solidify, you will get this product. So it's very easy to manufacture using plastic. So now here you can have n number of cavities at a time. So like if you increase the size of mold and the capacity of machine, so you get 100 cavity, 200 cavities, 500 cavities. So you can make according to the capacity of your machine. The machine capacity depends on the liquid injection capacity. So now like my machine is 10 gram injection capacity. So 10 gram injection capacity is like, I can, if my part is of 1 gram and then wastage is of like 0.2 gram, I can make 8 to 9 products at a time and in one stroke. So this is called as like this is the example of injection molding or any type of electronic device. This is the leg where this is a suction and then it gets sucked to your table or the glass. Then this is the base, or this is called as a gasket used for sealing something. This is again the O-ring which is used for hydraulic application wherever like there is a problem of liquid leakage. And then this is again the small O-ring, and this if you see, this is again one full pad of rubber molding where like this has been done by the mold, and then you just tore it and you get one O-ring. So now it's very easy to tore, like you can just tore it, move it, and then you have to remove the inner flash. So this is called as flash, which is wastage. Actually in rubber there is no wastage. You can again melt and again make it. So you get a O-ring here. Okay. So now how rubber molding is made? It's very simple. You take a rubber raw material, cut it into according to the piece, put it into die, heat the die, and then the rubber fills the gap wherever there is a cavity, and then you solidify it and you get the shape of rubber. So rubber molding is simplest part of rubber molding process. Third is blow molding. Everybody knows we use too much of sugar drinks, like the bottle are made with the help of blow molding. Okay, so this is blow molding. So these are the tires of horse which are being used by kids. In the blow molding there is a cavity, and then in the cavity you just blow with the help of air. So now if I have something like this, and then I have sealed this with the help of, and if I am air pressure, so if I blow air, it will fill this cavity, and according to air pressure you get the thickness of this blow molding. So accordingly you can control the thickness of your bottle or some kind of barrel. So you can have according to the thickness. Ideal thickness can be controlled with the help of air pressure, and this is the way blow molding is being done. Now next goes transfer mold. Transfer mold is same as like we did in rubber mold. Rubber mold is also transfer mold, that is we are transferring the pressure, heating it and preheating it, and then transferring the raw material to the cavity. So it's a transfer mold. So now last is extrusion mold. Extrusion mold, straw. We use straw. Then the straw is extruded from the die, and then you cut according to your size. So this is where the straw is. So next goes forging dies. Okay, what is forging? Whenever the shape of the component is very difficult to achieve with the help of machines, so we can make a mold of that and press it. So if you see some examples of forging dies, forging components, so these are the forging components. Okay, so here if I want to make it with the help of machine, I have to take this much big shaft or this much big iron piece and then machine it with the help of like 8 to 10 type of machines, and then I will get this product. But if I have a forging component, if I make it this with the help of forging, I can just make it in one stroke and then machine it to the final shape. So another example everybody knows is the spanner used in day-to-day life. Okay, so if I want to make this shape what I have to do is I have to take this much big size of plate and then cut it, make the shape this, again make this shape, and then form. But whereas then I can even imprint my logo, my engraving on it. So this can be done easily with the help of forging. So you then again, you know, this is a clamp highly used in engineering industry, so to clamp the products. So now these are also used in this can be done easily by forging. I can make this shape with the help of forging and then just machine these two things. Again, if I want to make this product, with the help of machining, I have to totally get a big bar and then machine it, like making it like from 10 kg to 1 kg, and then wasting material, that is national loss. So if I make this shape, I just keep 2 to 3 mm extra, I can get this product easily. So forging is like, forging dies are two types, like one is hot forging and another is cold forging. Cold forging, everybody knows that you go to blacksmith and what he does is he just puts on anvil, press it, hits it with hammer. So when you hit it with hammer, you get the shape whatever you want. If you have some kind of shape in the bottom, the steel will acquire that shape. And then hot forging is like where you have very high complex shape and heavy material. You heat it to some 800 degrees, 700 degrees, and then just put it in the hammer press. Okay, so now we are done with forging dies. Now I will go with die casting dies. Again, same concept applies for the forging dies, where you have very high complex shape. You can go with forging dies, but then you have die casting dies. Die casting dies and forging differs. Both are used for wherever you have a shape. You require shape, but forging is used where like you need a heavy pressure. And because when in die casting dies the product comes out in a brittle nature, so you cannot use it as a tool. So wherever just a base is required, like if you see the engine block of your car, that the block is made with the help of casting. Like if you have highly complex shape, you can use die casting dies. So casting is like sand casting, where the shape and like you have high tolerance, like when you require, like when 4 to 5 mm is not a big problem, so you use sand casting. It's a very easy process. You make mold out of sand and just pour in the material in that. Then gravity casting and then pressure casting. So gravity casting is same, like with the help of, you can just pour material with the help of gravity, and pressure is you pressurize. Yeah, like you flow the molten iron with the help of pressure. So here you get good accuracy. In this. So wherever there is highly accurate product, you use pressurized die casting. Now jigs and fixtures. Okay, jigs and fixtures are used wherever you require. Like you are machining something, and then if I need to machine this product, and then I have to give a slot here. So what I have to do is I have to hold this product here, and then if the slot, if my slot is like, if my slot is here, so now I need exactly the machining, the cutting should start here. So what I will do is a location and holding. Okay, so this I will be covering when I will be taking jigs and fixture as a full topic for video in detail, and designing how to design jigs and fixtures according to different machines. So now there are assembly fixtures, like if you have, so now if you have assembly fixture is like if you are assembling your car, so you have to assemble different type of parts, and then you have fixture and just press it, fixture and just press it. Then you have welding fixture, like if you are welding different body parts of car, and then when you are like welding different body parts of car, maybe like CO2 welding or arc welding or spot welding, so you need some fixture so that they are located and you just put a spot. Then you have machining fixture, that is like you are holding on the machining and then giving a cut. You are giving CNC fixtures, VMC fixtures. There are a lot of different kind of fixtures where you require a holding and guiding. Then you have drilling jig, then you have grinding fixtures where you are grinding the product and then you are locating it with the help of that. Then you have drilling fixtures drilling jigs. In fact, jigs and fixtures. So here is drilling jig. Jig is a place where if I have a flange and then I have to pierce 8 holes on this, and then these are the PCD of, like, say, dia 300. So if I cannot take this every time with the help of just marking it and doing it. So what I will do is I will make one jig plate, put it on it, and just guide the drill with the help of it. So difference between fixtures and jig is fixture doesn't guide the tool. Tool is independent. But in jig, you guide the drill. You guide the drill jig, that is drill with the help of jig, maybe with the help of bush or something like drill with the help of bush. So there are a lot of other things to guide with the help of drill. And then you have tapping jig, same as drilling jig. When you need to do threading on these holes, you need to guide with the help of that. So now if we go ahead with inspection gauges, okay. So inspection gauges are the thing like if you're producing some product, like to say example, if you're producing the body of this pen. So now if take an example, the body of this pen is of dimension 12 mm. So now every time when it comes out of the machine, I cannot take a vernier and measure it and check it. Okay, it's okay. So now I can have some different kind of gauges to measure just if it is passes, it's go. If it doesn't passes, no go. So we can have go, no go gauges where the operator or the unskilled operator can easily understand that my product is coming manufacturing okay or not okay. So now if I will just take an example of this. So if this, I need to measure the diameter, the outer diameter of this pin. So now what I can do is like make some snap gauge, okay, and so this dimension will be, say example, dia 10, and then if I make a step here, and then this dimension is dia 10.2. So now if this pin enters this place, then it is rejected. That means the dimension is out of our control. So operator can easily see, just enter that piece and just put it aside in okay or not okay barrel. Same like if I go, there are different type of inspection gauges, that is pin gauges. Like if I need to measure this hole, so I can measure with the help of this type of pin. So if this pin enters, it's okay. If it doesn't enter, it is rejected. So I can have go, no go pin. So if you see go pin gauges, snap gauges, this is snap gauge. Now I can have pin gauges where it is a pin protruding here on this, and then this side there's a pin. So now here go dimension, here it is no go dimension. So if this enters, it is okay. If this enters, it is rejected. Okay, so now we have relation gauges. So if you have very complicated shape like assembly of a car, and you need to understand that the assembly is being fitted right. So if it is like different type of shape, and then I need to check this assembly is right. So I will make one relation gauge which will match the shape of this product, and if it matches, it says go. If it doesn't matches, it can say. So there are different type of gauges which can make your manufacturing. And then we have cutting tools. Cutting tools, there are different type of cutting tools like drills, reamers, milling cutters, lathe tools, that is turning tools. Then we have broaches, cutting blades, like these are the cutting blades like you can, or like used on hacksaw blade. So like if you see, when you need to cut or some part something, you can like if I have a job and then I need to cut it here. So what I can do is like I can have a blade which is being installed on the pulleys, and then I can put a job here. So this is a blade, and then this cuts with the help of its cutting edges. So this blade has got a cutting edges at the bottom. So this type of cutting edges at the bottom, so which so if we see different type of milling cutters, there are end mills, there are 2 flute mills, 4 flute mills. According to the job, we have to decide and use that type of cutting tools. Then last, we have got general tools. General tools are like we use in day-to-day life, even if in workshop or in different type of garages, everywhere where we use that like we are hammer, chisel, knife, saw I just showed you, then screwdriver. So you use these type of tools to do like small or big activities, like even if you're home, even to fit even if you want to fit the nail to your wall, you have to use lot of different type of tool like hammer and drill machines and all that. So without tool, it's like we cannot live. A tool is a life. Even if you see the modern life, if you have a robot, you need a gripper to hold, like a robot gives a motion, but to really do the task you need tools, like you have a gripper on the motion, then you have suction cup on the robot. So it's really impossible to delete the tools from our life. So friends, if you like my video, just press subscribe to my channel and also hit like. Then my next video will be on like sheet metal press tool, that is blanking and piercing die. I will start covering small concept on it. So okay friends, have a great day.